Swayam Prabha. Digital India. Educated India.
Welcome to Module 6, Lecture 26, that is on environmental degradation of materials and surface engineering, under which we will discuss about different characterization and testing techniques. Those are applied for the measurement of characterization of surface as well as measurement of different properties of the surface, as we discussed earlier. So, characterization play a very important role. Different characterization techniques are very important actually, because unless and until you use them, we won't be able to know many important parameters of the surface. For example, if you talk about surface parameters, they are mainly surface roughness. If you talk about surface treatment, then coating surface treatment thickness. If you think of applying coating, then coating thickness, then microstructure and composition of the surface, and different properties like hardness, wear, corrosion resistance, those properties of the surface which you are either trying to tailor or maybe you are trying to investigate or measure. Those are very important, and those all are under characterization and testing techniques. So, whenever we talk about characterization, we discuss about those tools which are used to know the characteristics of the surface. So, characteristics of the surface means, if you talk about the different surface characteristics, they are like defect density, they are microstructure and composition of the surface, phase, texture of the surface microstructure, the roughness of the surface, and also the state of stress, and also the residual stress which is arrested on the surface after different surface treatment or maybe after different processing. So, those are important surface characteristics which need to be evaluated, because unless and until you evaluate or just document them, it is very important to know the properties or how the surface is influencing the properties of the component, particularly surface properties of the component. For example, if you talk about defect density, if there are defects on the surface, certainly it is not good, because that will deteriorate the chemical properties like corrosion resistance, mechanical properties like wear resistance. It would also deteriorate fatigue property, and so different properties are deteriorated if defects are there on the surface. Similarly, microstructure and composition, they play very important role to determine the mechanical properties, particularly hardness as well as wear resistance of the surface, fatigue strength of the surface. They also influence the typical corrosion resistance and also high temperature oxidation resistance property. And whenever you talk about microstructure, it is consisting of several components like grain size and grain size distribution, the phases which are there in the microstructure, the morphology at which the microstructure, the grains are growing, and also the texture, that is at the direction where the grains are growing. So, microstructure consists of several components like size of the individual constituents of the microstructure and its distribution, the phases which are there in the microstructure, and also the direction at which it is growing. And finally, composition is also integral part, because unless and until composition is known to you, the microstructure remaining the same composition can also vary. For example, when you add any element into the any other element, like if you just go on thinking of solid solution of nickel in copper, you will find that the microstructure may remain same if, for example, 10 to 25, for example, nickel is highly soluble in copper. So, whenever you go on observing the microstructure of pure copper and nickel added copper, you will find that microstructure may remain same, but unless and until you know the composition or you determine the composition, analyze the composition, you won't be able to distinguish whether it is pure copper or nickel added copper. Similarly, if you talk about phase is also very important. Unless and until phases are known to you, it is very difficult to know what is there. For example, microstructure constituents which are there in the microstructure, those constituents need to be identified. So, you have to go phase analysis, or you have to do phase analysis to know what constituents of phases are there. That can be determined by X-ray diffraction technique, and subsequently the plane at which the microstructural constituents are growing or they are oriented, that is called the texture. So, you will get information about the texture by X-ray diffraction analysis, as well as that electron backscattered the diffraction technique. And microstructural observation can be done, or about the microstructure you will be able to know from optical microscope, scanning electron microscope, as well as transmission electron microscope. So, microstructure, composition, phase, texture, they are basically major components of structure of the material. So, structure of the component. So, these are very important to be characterized. Now, apart from these particular constituents of the structure, we have to also understand the defects which are present, which are usually the after effect of the processing. So, you have to know what techniques should be applied to know the defect density on the surface or deep inside the surface. So, there are different tools which may be used for understanding or to evaluate the defect density, like different non-destructive testing based tools, or different usually non-destructive testing based tools are used, or X-ray micro CT scanning or gamma ray scanning. So, those techniques or different for example, that is the magnetic particle inspection testing, then ultrasonic testing, those all techniques are applied for knowing the defect density of the component, which are present on the surface or maybe in the subsurface region, which greatly influences the surface property as well as the bulk properties. And finally, roughness is very important parameter, which is manageable, but roughness also influences, or when the surface is very rough, you will find that its properties like corrosion resistance is greatly influenced, because your surface area effective surface area increases, as a result of which the chemical property basically deteriorates. And also when there are surface roughnesses or many rough points or troughs are there on the surface, those basically points act as the points of stress concentration or stress reserve. So, certainly you will find that many of the particular defects, like, or maybe you can say that damage initiates from the particular points where there is stress concentration, like fatigue crack initiation, or maybe heating corrosion initiation, or stress corrosion cracking initiation. So, roughness also plays a very important role. So, roughness, if you just think of different techniques which are applied for measurement of roughness, they are basically different profilometer, maybe laser profilometer, then optical profilometer, atomic force microscopy, and also you can say scanning tunneling microscopy. So, you have to know at which scale you are observing the roughness of the material. So, depending on the scale, it may be micro scale, it may be nano scale, it may be atomic scale. So, depending on the scale which you are looking for, the tools will also vary. Tools also you have to accordingly choose. Now, this particular talk I will briefly discuss about the techniques which are applied for the determination of defect density of the component. So, if you just quickly go through the techniques usually applied for defect density after the manufacturing stage, those are, first technique is nothing but very easy way of detection of defects is by visual inspection. So, what you do basically when the component is ready, you basically visually observe it either by unaided eye, or maybe you can also use typical magnifying glass to know the defect content on the surface. So, when the defect contents are of very high magnitude, like if it is macro cracks on the surface, or if it is highly wavy surface, if it is not flat. So, if there are many intrusions on the surface, or if there is some deposition on the surface, so those defects may be observed by visual observation, or may be concluded on by visual observation. So, if you just quickly, and second type of test which are widely used for measurement of defect density is the non-destructive testing. So, non-destructive testing is having advantages over other techniques is that you can directly know the defect content of the material or some cases some properties of the material without damaging the component as a whole. So, you use it. So, that is why the name of the techniques are called non-destructive testing. Now, if you quickly go through the visual observation tools which are applied for visual observation of the structure, they may be magnifying glass, like you can see if crack size is very small, you can magnify it and find it out. If surface apparently looks oxide free or any other highly lustrous, but if you just observe it by magnifying glass, you may see some of the deposition which are there on the surface, very small tiny inclusions which are there on the surface may be detected by magnifying glass. Similarly, advanced videoscopy or videoscope can also be applied to know the defects, and also for a large structure you can go on recording that particular defects by typical videoscope at low magnification, and subsequently you can go on analyzing it at a later stage to know actually which defects are there at which position. So, those are very interesting tools for knowing the defect density, but provided the defects are on the surface and they are of very large size and dimensions, and those are easily detectable. But some cases you will find that these all defects are not really on the surface, they are also deep inside the base of the material. So, there if you are interested to know the defects, then you have to go for non-destructive testing techniques. So, the kind of non-destructive techniques which are applied for the measurement of the defect density of the material either on the surface or maybe it is the subsurface regions, they are liquid penetrant test, then magnetic particle inspection, eddy current testing, ultrasound testing, ultrasonic testing and radiography. So, if you just quickly go through the individual techniques, you will find that each technique is having its own limitations and advantages. So, advantages are there, for example, if you talk about simplicity or maybe easiest non-destructive testing based techniques as shown here, among them you will find that liquid penetration test, liquid penetrant test is the easiest one which may be applied for the detection of the surface defects, surface porosities, surface micro cracks, those things can be determined by liquid penetration test. Similarly, if you talk about magnetic particle testing, that technique is also applied for knowing the surface defects. But disadvantage is that liquid penetrant test cannot detect the kind of defects which are there deep inside the material. Same for magnetic particle test. Magnetic particle test, another disadvantage is that this is mainly applied for magnetic material, it cannot be applied for non-magnetic materials. Similarly, eddy current testing, again you can have variable depth by changing the magnetic strength actually, and subsequently you can know the eddy current density. Similarly, ultrasonic testing also, it is having some limitations on the thickness, but it can go up to the certain micrometer of the subsurface region to know the defects which are present on the surface and as well as subsurface region. So, among these all techniques, radiography is the technique which is having maximum depth of penetration. So, these techniques are usually, this technique is usually applied for the measurement as well as detection of the subsurface defects and also the defects which are present deep inside the component, even maybe at a larger depth or all throughout the material, whatever defects are there, that can be detected by radiography technique. So, you understand that each techniques is having, so if you talk about cost, you will find that cost wise liquid penetration test, liquid penetrant test is quite cheap and also it is easily available, it does not require much of the operator skill, anybody can operate or use the liquid penetrant test. Magnetic particle testing is also very easy to operate, this is also not really so expensive technique. Eddy current testing eddy current testing is also quite easy, but certainly it is not one-to-one correlation, you have to always you have to always analyze the results. Same for ultrasonic testing, and radiography is also not really so easy, it needs a little bit of operator skill. it is also quite expensive technique, and also radiography also directly gives you with the help of software, you can get information about the location of the defects and also the mass fraction of the, also the area fraction or volume fraction of defects, where is it present, these all things you can determine from the radiography testing. Now, quickly going through all the techniques one after another. So, first as I mentioned you, the dye penetrant testing. Dye penetrant testing is very easy testing and can be applied for the detection of the surface defects. Surface defects may be porosity, surface defects may be micro cracks, surface defects may be macro cracks. So, these all defects may be determined or detected by dye penetration testing. So, in this testing is very easy, as I mentioned, anybody can apply it. So, for this testing the mandatory criteria is that surface has to be cleaned properly. So, if you would like to clean the surface, certainly you mean to say that it has to be free from any kind of greasy layer or any kind of if any contaminants present on the surface, and also maybe some oxides if present on the surface. So, that surface you have to remove actually those oxides layer or greasy layer. So, there are several ways of cleaning the surface which will be discussed later, like you can, if it is greasy layer or any oily layer on the surface, you can go on just dissolving it in organic solvent. If it is oxide layer, thick oxide layer present on the surface, you can go for pickling operation. So, like that different, or if it is very thin oxide, you can go for alkaline dissolving of, for example, if oxides are there or aluminum on stainless steel, you can go for particularly aluminum if the oxides are there, titanium oxides are there, you can go for typical that caustic soda cleaning. So, you can remove those oxides layer by different ways as is required for the specific oxidation oxide scale, and then after the surface is clean, you have to basically you have to go on cleaning and then you have to cleansing the surface. Cleansing means you have to go on, after cleaning you have to go on rinsing the surface. You can rinse it in water or alcohol, and then you have to apply the penetrant. So, usually different types of penetrants are applied, those are actually patented in nature. So, it is available in market. So, you can apply visual penetrant, which is usually visible penetrant, which is usually red in color. So, you can easily apply that so that it is visible and it is quite prompt whenever you apply the developer after that. So, even though you just remove the developer, the penetrant will be visible. You can also use that typical fluorescent penetrant, so for deeper level of penetration. So, after the penetrant is applied, you have to remove the excess penetrant from the surface by typical this cleaning it in water or alcohol, and as soon as you remove it, naturally some penetrants will be there deep inside the surface. It is in the form of where porosities or defects are there, penetrants will remain inside, and then after that you apply developer. Developer is usually white powder which is applied, which is sprinkled on the surface. It is in solution, white powder dispersed in solution. So, you have to apply the developer. So, as soon as you have applied the developer, then you have to wait for certain period of time, and then you check it under microscope, normal optical microscope. You will find that wherever there are no defects or there is no defect, nothing is visible, but wherever there are defects, you will find that the red color is it is defects are in the form of red colored zone. That may be porosities, that may be micro cracks, that may be macro cracks. So, those defect density you measure by measuring the surface area of the red colored zone, and which will give you information about the typical defect density present on the surface. This dye penetrant test is very easy technique. So, as a result of which it can be applied for any surface processing, like if you just do any surface processing like surface melting, or you do surface alloying, or maybe you do surface hardening. Then after that you clean the surface, or you apply any coating, you just go on cleaning the surface and do dye penetrant test, and you find out whether it is defect free or defects are there on the surface. So, this is the typical this is a typical protocol which are used, or the steps which are followed. So, like you have to do surface preparation by pre-cleaning, then it may be that is water washable, it may be post emulsifiable, or maybe solvent removable. So, it can be anything depending on the surface composition, whether there is any greasy layer or where is any oxide layer or whatever may be there. So, it has to be cleaned properly, and then you have to go on applying the just penetrant, and naturally you have to, after application of the penetrant, you have to remove it certainly, because you have to, the penetrant should not be there on the surface. You have to wait for a while and then you have to remove it. You have to check carefully whether it has removed properly, and then you have to apply the developer may be powder or water soluble, water suspensible or solvent based developer, and you have to inspect it by optical microscopy, then record it, and then you have to clean and protect it. Certainly these are the things which, these are the steps which are followed for the liquid penetrant testing. So, liquid penetrant inspection can be used for inspection of flaws and break on the the surface of the samples. The flaws which are can be determined, there may be fatigue cracks, there may be quench cracks, there may be grinding cracks, there may be overload and impact fractures, porosities, laps, seams, then pinholes in welds, or lack of fusion or brazing along the edge of the bond line. So, this anything can be detected by the liquid penetrant testing. So, you can also use the liquid penetrant testing on the site actually. For example, this is a case for like you have a kind of roof where that is and this is the corner of the roof, junction point of the roof, and you will find that if you apply the dye penetrant testing, so big cracks are visible over there. Similarly, in pipeline, water or oil pipeline, if you go on applying the dye penetrant test, you will find that the location of the cracks would be visible. So, these things can also be applied on site, and it is very easy way of detection of the cracks which are very big in nature. Second type of testing is magnetic particle inspection testing. This is also equally easier. So, but the disadvantage of this testing is that this magnetic particle inspection is that this can be only applied for the magnetic material. This is not really a very good technique for non-magnetic material. So, on magnetic materials, if any flaws are there, so that can be determined by the magnetic particle inspection. So, so this is a typical weld zone where basically you just go on applying that typical magnetic particles on the surface, and then you apply a permanent magnet or a temporary magnet over there. So, we will see that magnetic particles gets basically they are aligned as per the based on the direction or the area which is covered under the magnet, and if there are any flaws or any discontinuities on the surface, you will find that particular they will not be there on that particular zone. So, you will from the determination of the discontinuities or where the particular magnetic particles are not there, from that point you can from that location of the point you can determine the zone of the flaws or zone of the any defects which are present on the surface. So, this is what is saying that fluid in this case particularly people do use either loose magnetic particles in the form of powder or particles. You can also use suspended magnetic particles which is applied here on the weld zone, and then you have to cracks makes the magnetic field, and this causes the particles to pull into the cracks if cracks are there. And then if fluid is sensitive to UV light, this allows for even clearer readable for weld flaws. So, if it is UV light visible, so naturally you can also clearly check it using the UV light. So, this particular technique again is a very good technique for detection of surface and a little bit subsurface cracks, but this is not a good technique for the non-magnetic materials. So, here again the steps which you should follow is that you have to go for cleaning the surface. The part surface should be cleaned and dried before inspection. Contaminants need to be removed from the surface. Then you have to apply the magnetic field. So, magnetic field can be introduced on the component in a number of ways, like by permanent magnet, or flowing an electrical current through the specimen, or flowing an electrical current through a coil or wire. You can apply the magnetic field. And then certainly you have to, before application of magnetic field, certainly you have to also go on applying the magnetic particles on the surface, and then subsequently you have to detect it where the, if there is any discontinuities or so from the alignment of the magnetic particles on the surface in presence of the magnetic field. So, this is again, advantages are can be applied for surface and subsurface defects, but depth of penetration is not really so high. It can be of the order of several millimeters only. Some inspection formats are extremely portable and low cost. This is rapid inspection and with immediate results, and indications are visible to the inspector directly. It can detect defects that have been smeared over, can inspect parts with regular shapes, but can be applied only for ferromagnetic material. Paint thicker than 0.05 inch must be removed before inspection. Certainly, if paints are there, it will not be able to penetrate through paint. So, you have to remove it. Post cleaning and post magnetization is often necessary. Maximum depth sensitivity is typically 0.1 inch, and alignment between magnetic flux and defect is also very important. So, third kind of testing is eddy current testing. So, here what you do is that you just go on applying an alternating magnetic field on the surface, AC magnetic field, which induces a eddy current in the material. So, again wherever the flaws are there, you will find that if you go on detecting the or recording the that current actually, so as a function of distance, wherever there are flaws you will find that there is no current. So, from the location or from the signal itself, you have to determine the defects and the locations actually. So, this is again very easy way. For example, these are the typical magnetic wire that this electrical currents are recorded. So, where there are flaws, you see the currents are basically there is a change in signal of the current. So, here and here. So, from there you can determine the defects which are present on the surface. So, eddy current testing may also be applied for coating thickness measurement, like when there is non-conductive coating on electrically conductive substrate, it can be measured very accurately using eddy current inspection. So, that coating displaces the eddy current probe from the conductive base material, and this weakens the strength of the eddy current. The reduction in length can be measured and related to the coating thickness. So, this is a kind of that is a indirect way of measurement of coating thickness, but there are so many eddy current based coating thickness measurement units which are fabricated, which and easily it is available in the market. So, this is very much successful way of measurement of the coating thickness when there is the conductivity difference between the coating and that of substrate. So, it is sensitive to small cracks and other defects. Defects of surface and near surface region can be detected. It is immediately results. So, equipment is very portable. So, eddy current based techniques can be taken easily anywhere and you can do the testing. Test probe does not need contact of the parts, but can be applied only for conductive materials. Surface must be accessible to the probe. Skill and trainings are required, which is more extensive, because you have to some extent you have to also analyze the data, which needs your a little bit background on those particular eddy current based techniques. Surface finish and roughness may interfere. Reference standards needed for setup. So, certainly these are actually reference standards are needed, because unless and until you know how the current these things will be, how the signals will be for whatever kind of defects, unless and until this is known to you, you will not be able to know. You have to model it and finally find out what kind of defects are there and what are their defects. And depth of penetration is limited. Flaws such as delaminations that lie parallel to the probe coil and probe scan direction is undetectable. So, you have to be very much careful about the not all kind of flaws are detectable using the eddy current based technique. So, finally, ultrasonic testing is a very important technique where you basically apply ultrasound, and from the ultrasound signal you determine the defects which are present on the surface. So, whenever you are detecting, you are basically just applying ultrasound. It may be longitudinal, shear waves, surface waves or lamp waves. So, any kind of waves can be applied. So, what you do is that waves are introduced on the material where they travel in a straight line and constant speed is maintained, and usually the probe has a piezoelectric crystal in which which is excited extremely short electrical discharge and causing it to vibrate and produce ultrasonic wave, and it is coupled to the surface of the test object with a liquid or coupling paste, so that the sound waves from the probe are able to be transmitted very easily in the test object. And then operator scans the test object and he moves the probe, he rasters it over the surface, and at surface interfaces some of the wave energy is reflected and some is transmitted. So, the amount of reflected and transmitted energy can be detected and provides information about the size of the reflector, and travel time of the sound can be measured, and this provides the information on the distance that the sound has traveled. So, for example, if you have this particular, if you go on applying the ultrasound, then naturally you will find that the depth of its penetration will be varying if there are flaws on in the deep inside the material. So, if your thickness is known to you and if you know what should be the depth of penetration of the sound, naturally if there are any defects you can always compare it with standard specimen, standard component, and find out the location of the defects from the discontinuities in the wave of the ultrasound. It is having relatively higher penetration power and more sensitive. So, one side of the object is accessible only. There is no size, it can estimate size, shape and orientation and nature of defects, and it is non-hazardous. All the techniques are discussed except the dye penetration one is non-hazardous. There is no chemical which is involved over there. It is automated and immediate result can be obtained, allowing for immediate decisions to be made directly. Limitations are required experienced technician for data interpretation. Sometimes false results are there. So, you have to know which situation, which case should be how the wave or how the signal will look like. The objects can be which are rough, actually irregularly shaped, that is difficult to inspect. Loose scales if they are there on the surface, like if there is any oxide scale on the surface, it needs to be removed, and it is very much sensitive for it is having very sensitive to surface discontinuities, but if there are discontinuities in the subsurface regions long below the surface, like volumetric defects and inclusions if they are there, so that it cannot be determined by the ultrasonic testing. So, again it is to some extent surface and little bit subsurface defects can be determined by ultrasonic testing. But it is having a lot of applications in industry. It can be performed for both ferrous and non-ferrous materials, in contrast to that eddy current based technique or in contrast to that of magnetic particle inspection technique. It is capable of detecting finer defects, and the applications involve any component for aerospace, automotive, construction, rail, medical and oil and gas industries. Then finally, radiographic testing is very important technique which can be applied for detection of the volume defect actually. So, here X-ray or gamma ray is used to produce radiograph of a specimen and showing any thickness, if there is any changing in, if there are presence of any voids or any defects in deep inside the material, it can be easily determined from the signal of the X-ray or gamma ray, because there would be, if voids are there, naturally it cannot penetrate. So, there would be that if you see the radiographic image, you will see that voids are directly visible. So, earlier days people used to use radiographic plates for knowing the detection of the, for detecting that particular flaws or discontinuities, but these days people do use different software, and from the density difference between the this particular metal and that of flaws or inclusions, you can easily determine the zone location of the defects, and also what are the defect densities. These all things can be determined very easily. This is a slow and expensive NDT, but this is the only technique which can be applied for the detection of the bulk defects, maybe macro, micro or nano level. So, depending on the kind of defects you are applying for, you have to use the energy density of the X-ray accordingly. So, there are several advantages. So, it is very easy technique, in that sense. It is not really so much difficult, and the chances of flaws or artifact effect is minimum over here. You can directly see the defect contents inside the metal. So, no surface penetration preparation is required. It is volumetric in nature, suitable for inspection of assembled component, suitable for inside and on stream inspection. Many different types of materials it can be applied, and permanent record can be made out of the radiographic testing. Limitations are hazardous, ionization radiation requires, it is naturally whenever X-rays or gamma rays are there, you have to be very much careful, you have to take protective measure. It is a little bit expensive, it is slow process, obviously it takes a little more time. For example, one sample takes 2-3 hours to get the better resolution. It is sensitive to flaw orientation, are not possible to determine depth of indications, and two-sided access to test the objectives is required. That is always good, and it is having applications in aerospace, marine, offshore, power generator, petrochemical, waste management, automotive manufacturing or transport industries, anywhere as you wish. So, finally, the microcomputer tomography is nothing but the same things based on the concept of, as is there, that radiography, but here you use X-ray as a source, and this is having very low energy. So, what you use is that if you use X-ray, it is scanned over the surface, and you can detect the defects in a slice by slice fashion, and with the help of CAD modeling, finally you go on observing the 3D images of the defects or of the surface and location of the defects. Everything is possible with this particular technique, computer tomography technique. This is very much applied for determination of the defects in the metal foam, for example, or maybe porous materials which you are particularly designing for specific purpose of your requirement. So, this is naturally quite good technique. So, now just will that after this all techniques we will try to understand the different destructive testings which are used for measurement of the surface properties like hardness, wear resistance, fatigue and corrosion resistance properties. And certainly in the next class we will discuss about the mechanical properties like hardness, wear resistance, fatigue strength, how they are determined, and subsequently the different corrosion resistance properties, different types of corrosion resistance which can be determined by different way those techniques, testing techniques will be applied. And finally, we will discuss about some important tools which may be applied for characterization of surface roughness, to measure the surface energy, to know the surface microstructure and surface composition. And so naturally, in this talk we discussed about what is the importance of non-destructive technique for characterization of the surface, what are the different classifications of the non-destructive technique, advantage of and disadvantages of different techniques, which is very important to know. Unless and until you know the pros and cons of individual technique, you cannot apply it accordingly. And certainly the application of different tools are also, where to apply which one is also very important. So, that also we discussed about in this class. So, these are the references which you can follow for this particular non-destructive testing, and Thank you so much.